Of applications. We have speech recognition, we have speech synthesis, all of the machine learning tools on the cloud platforms, and now on Raspberry Pis and the like. We have dynamic generation of audio. We have various DSP processing. We have real-time fraud detection that we can do by audio analysis and injection of live feedback, and all of these really exciting applications. And again, we're kind of hamstrung with how do we get audio out and shove audio in a real-time basis. So that's not to say we don't have existing solutions. We do. For instance, Chan ALSA, or if you have a really ancient system, Chan OSS. These are basically means of getting audio directly to and from Asterisk and a sound card. So that's great for getting one call on one node and getting an analog signal that you can then maybe pipe into some other source, but it's not really a scalable solution, and it's not really very useful for interacting with other applications. So we have AppJack. So this is a local sound server which switches audio from one input to an output. So it's not hardware bound, so we don't have to worry about a single audio card, but it is node bound. It's not network oriented. It's not really scalable. The connections that you make with Jack are semi-static. It requires a lot of latency and effort to change those plugs from one to the other. It's also a dial plan application, which means you can't use it with things like ARI. And there are lots of really buggy implementations of it. So Chan NBS looks on the surface exactly like what we want. It's a relatively simple protocol. It's a channel interface, which means we can use it with any of the APIs in Asterisk. It's network oriented. Unfortunately, the module itself is deprecated. It's undocumented. Good luck in finding any documentation online. Google completely failed me in this. And there appear to be no implementation server-side or client-side other than those in the Asterisk module itself. So, the one most people use is MRCP. It is an open source server, an open protocol. There are some commercial products that interface with it. LumenVox comes to mind quickly. But the protocol itself is very complex. It's an XML-based system. It's a nightmare to try and implement on your own. And unfortunately, the UniMRCP server, while the server itself is open source and the plugins are nominally documented, building plugins for it is equally difficult and requires more documentation than they really give. There are closed source proprietary plugins for it that allow you to plug into things like AWS and GCP's machine learning, but even after you get that, you find that it's an extremely expensive option. Despite the server being open source, the plugins are pay to play and a pay per port. And it very quickly, at scale, gets very expensive. So then we have Chan RTP. Now this is a really simple channel driver that just simply encapsulates the audio that probably already came into Asterisk in a bare RTP channel. It has some additional signaling that is kind of assumed and derived from existing channels. The protocol itself is copiously documented. It's natural for VoIP endpoints because it is the fundamental real-time audio protocol that's used in VoIP. However, if you're trying to interface with applications that are outside of the VoIP world, it's not a very easy protocol to implement. It has no non-VoIP implementations to speak of, and it is generally tied to SIP. Even in Asterisk, it's referenced from from referred zip originators. So it will work, but it's quite a bit of effort to make it work for external programs that are not voice-oriented. So what we have now, and the purpose of this talk, is to demonstrate the audio socket. So audio socket I briefly demonstrated last year here as part of the talk, the application interface. And application interfaces, as we mentioned before, have the limitation of they're only really good for dial plan applications, which means ARI is pretty much useless. So the big addition this year is adding a channel interface for audio socket. But first, what is audio socket? So it's a network-first protocol. It requires no telephony knowledge to use, and the protocol itself is dead simple. It's a 3-byte header and a stream of audio data, signed linear data. It is a greenfield project, so it's completely opinionated. There are no options. You just simply start it, send the unique identifier, tell it you're going to send signed linear, and then start streaming. There are very few control codes that all fit within the single byte type indicator, and this can be easily implemented in any language. We do offer both an application interface and a channel interface, but also a server library interface, at least for the Go side, and other people have built server libraries in Java and in C++. So it is also fully open source. There are no proprietary aspects to this. The Go side, the server side, is in Apache 2 license, and the Asterisk side is GPL. In order to use it, the channel driver just looks like any other. You have the channel type, audio socket. You tell it the server that you should be connecting to by host name and port number, or IP address and port number. And then you give it a unique ID. So this is the one requirement of audio socket, is that every call gets a UUID. This is just simply so that you can track it between external applications and internal applications. It's a nice universal standardized identifier. It is not required that you pre-register it. These can be randomly generated if you don't need them on the application side, but it is required to operate the system. Likewise, as with the previous version, there's also still the application interface by which you can just call audio socket from the dial plan and pipe that to whatever server is running your audio socket. So these are the repos that you can find audio socket, as well as the demo application that I will be attempting to do here. It's been crashing quite a bit, so I might be able to get something, but we'll see. Unfortunately, this isn't dangerous demo, so I don't get the prize for abstract failures. Let's see. Try it without the audio here. So I think we've just got audio problems. It seems to be working on the phone. Is this turned on? The should go. Try it once more. If not, I win the crash and burn.
Hello. How may I help you?
Scale asterisk up 12 instances.
Sorry, I don't know how to do that.
Scale asterisk to 12 instances.
Sorry, I can only scale to 10 asterisk instances.
Okay, scale asterisk to 10 instances.
Sorry, I don't know how to do that.
All right. The audio socket did work, yes. So that was streaming audio back and forth between, of course, Google's speech engine. Both the recognition and the synthesis were done via audio socket to the speech engine. All right. So, got a quick question. Is there any benefit to audio socket, the dial plan application, versus dial audio socket using the channel? And really, it's just the difference between running a dial plan application and running a channel. So, if you are not trying to do anything that requires a separate channel, the application interface is vastly easier. There's no additional bridging involved. There's no additional work that you have to do from ARI. You just call the dial plan application, send it give it in the parameters, the server you want to use, and you're done. Asterisk will automatically bridge it internally and have everything just fine. Now this works with dialing the channel also, but again, it's only one side of the circuit, so it's up to you to figure out the other side. The advantage of running inside the dial plan applications is it's just simpler. So, other than that, any questions?
Since this is over TCP, do you have any mechanisms to avoid latency buildup that a reliable transport causes?
So latency is buildup by what?
You get packet loss, so it's retransmitting, so it's falling farther and farther behind.
No, again, this is intended to just simply be able to transmit audio between 2 points. There is intended to be as simple as possible. So yeah, if you've got latency building up because you have retransmits and it's failing, that is, as far as the protocol is concerned, your problem. So there's no attempt to try and cut that down or chop off pieces and that kind of stuff. No.
I have a quick question as well. So you mentioned that you are using signed linear right now as the audio that you channel over the socket. Is it just narrow band, or are you also targeting different sampling rates there?
Yeah, so it is. So first of all, the protocol was designed in a way to handle any number of codecs. Right now, the only one I implement on the Asterisk side is 8 kilohertz 16-bit signed linear. That could be anything else in particular, but that's all I've designed for the protocol itself. There's no reason it couldn't be a wideband protocol. There's no particular limitation on that, other than the entirety of the size description has to fit in 2 bytes. The packet length, payload length description.
Any other question for Seán? Okay, do we have other slides, or is it? Do you have other slides, or were you done?
Nope. This is it.
Okay, then a big round of applause for Seán, please. Thank you.
All right. Thank you.